How volcanoes are formed. How volcanoes are formed. To understand the concept of volcanoes, first we need to understand the concept of ground and interior structure of the earth. This is the ground, this is the normal ground. They will live, they will reside, they will stay here, and we make houses and we live. But have you ever imagined what if we take a drilling machine like that and we start drilling the ground in the downward direction? We start drilling the ground in downward direction. What will happen? So this is a drilling is done in the downward direction from the ground towards the core of the earth, and this is what we get in the first stage. So this is the topsoil, this is the subsoil, and this is the bedrock under the ground. So the direction of the drilling of the ground is like this. Now, here comes the first stage of drilling of the ground and volcano. This is called interior of the earth. The first layer is called crust. The beneath layer is called mantle, and the inside the ground there is core, which is divided into inner core and outer core. Now we have reached the first stage after drilling, and we have understood that there is crust, mantle, and core inside the ground. Next, we have made a hole inside the ground, and imagine someone's entering into the hole deep inside the ground. And one theory, one observation that we know that when we go deep inside the ground, the temperature increases. The temperature, it increases. That means some element inside the ground, when temperature goes up, they must be in the molten stage, because maintaining the solid state in such high temperature is practically impossible. So some elements are in molten stage and steams comes up. These steams are called convectional current. You need to remember that. And some are in semi-molten stage because the temperatures are high and the convectional currents are coming out of them. These steams are called convectional current. Likewise, this is called magma chamber. When we go deep inside the ground, the temperature rises and some things are in molten stage, and this molten stage, the molten elements are collected in a chamber, is called magma chamber. The temperature start here, we reach here, the temperature goes on increasing, and at this point everything starts melting, and these melted things are collected at a chamber. This chamber is called magma chamber, and this is the source of volcano. How it becomes the source of volcano, and how the magma chamber, which is deep inside the earth, that comes out to the ground and becomes the volcano. This is the topic of our video. Moving on. Likewise, when something is on boiled stage, something is on molten stage and boiling, the steams comes out. I have already mentioned the steams comes out. The steams finally at a point they hit the lid. At some point they hit the lid and they make it imbalance, and this is the concept of earthquake. Like this is the magma chamber deep inside the ground. The steams are coming up and they're hitting the upper part of the ground where we are standing. So this is the upper part of the ground where we are standing, and they're shaking the ground, making an earthquake. And this is the cause of destruction, and this is the concept behind earthquake. Now, this is devastation of earthquake. And now, here magma comes here, this is magma here, and it comes and hitting the ground. Now we need to understand the ground is not that simple that we think. The ground that we are standing, that we are sitting, is constantly on a movement. But the movement is so slow that we are not able to feel the movement in our day-to-day life on daily basis, because the grounds are made up of plate. The grounds are made up of plates. And you are standing on the plates and the plates are moving. We are standing on the plates and the plates are moving. But how big the size of plates? How big are the plates? So let me tell you, the plates are much bigger like this. Suppose you are in North America, suppose you are in USA, United States of America, you are in North American plate. So this is the size of North American plate, such big. That controls Canada, United States of America, Mexico, till there. If you are in Brazil, somewhere here, you are in South American plate. South America plate also consists of Atlantic Ocean. If you are somewhere down in the Pacific Ocean and island, you are on the Pacific plate. So this is the big Pacific plate here. So we are standing on the plates and the plates are moving, but the movement is so slow that we are not able to gauge the movement in our day-to-day life. Now, so this is asthenosphere. Asthenosphere is called the source of magma. The source of magma. And all the magmas are collected here. All the magmas are collected here, and they are releasing convectional current, which the convectional current hitting the ground and the ground starts moving. So what if this is the source of magma? Suppose one convectional current comes in this direction, another convectional comes in this direction, they hit the ground, and this part moves in this direction and this part moves in this direction, and this is a different plate Suppose this is North American plate and this is South American plate. This is South American plate and this is North American plate, and the convectional current, the magma chambers inside it in the molten stage, they're releasing convection current. One is in this direction, another was in this direction, and both the plates and both the grounds are moving towards each other. This is called convergent plate boundaries. Yes, this is the situation. One is moving this direction and another one is moving towards it, because the direction of the convectional current making it possible that they are moving towards each other. This is called convergent plate boundaries. So this is one very good example. In the figure, this one is in the direction and same one in this direction, and they're meeting at the point like that. So when the magma chambers are here, one direction is here, another direction is here. So when they are coming towards each other, the upper layer of the ground, the upper layer of the plate, they starts crumpled and they lifted upwards to make a mountain, and this is how mountains are formed. We have started the story from the ground. We reached till the interior structure of the earth. We reach the magma chambers. The magma chambers have convectional current in it. The convectional current hitting the ground and earthquake is possible. And now when the convectional currents are coming towards each other, they are crumpling the upper layer of the ground, upper layer of the plate, and lifting it upward, making it a mountain like this. And lifted upward and making a mountain. Now the mountains are formed. Now the direction are facing towards each other. Now what would happen? Depending upon the density and speed of the plates, one plate would subduct below the other. Now this is the plate, this is another plate. They're moving towards each other in their direction, but depending upon the speed and density, this plate will subduct below the other. So the final diagram will be like this. One plate is getting subducted toward each other like this. One plate has been subducted above the other plate like this. So this is the direction towards each other. And suppose a plate has oceanic element in it, that means the density would be higher and the speed would be higher. That means, suppose let's take an example of Pacific plate. The Pacific plate is entirely an oceanic plate, Pacific Ocean over it. So this has higher density, and due to higher density, it subducts below the continental plate, and this process is called subduction. This process is called subduction, and one plate scoots over the other, and this is called subduction. Now the plate has scooted over the other, and this zone is called subduction zone. Now this plate goes down till 200 kilometers. The concept of subduction is of 200 kilometers, and this plate subducting below and comes to 200 kilometers. And in 200 kilometers deep inside the ground, in that temperature, everything starts melting. And the plate which has come from this direction, now it collided with each other, the mountains are formed, now it is subducting below the other and entered into 200 kilometers zone. Now it starts melting due to high temperature. And this is extra magma that has been accumulated. And now this extra magma creating an imbalance comes out. Now this magma comes out and hit the mountain, top of the mountain, and blast like a volcano. So technically, the magma chamber is not the only region of creating a volcano, only region of the formation of the volcano. The plate tectonics, the colliding of the plate, one plate goes down below the other, and at 200 km when it starts melting, the extra magma that is accumulated, that extra magma tries to rise up, and to make balance, because imbalance has already been created, to make this balance, this extra magma is the cause of volcano in primal cases. In other cases, in divergent plate boundaries, the magma can directly come out, but we will understand in a different video. But this is the primal concept of volcano. And now, yes, this is subduction is happening, subduction, the subduction zone, one plate is coming towards the other. Now this is 200 kilometer mark, and at this it starts melting, magma has been accumulated, and this magma comes right to here, and this comes here, and it hits the top of the mountain. It's the top of the mountain, and it becomes volcano. Easy. Now this has been, the one is subducting here, this is lithosphere, this asthenosphere is called the magma chamber, asthenosphere. Now at the subduction point, when continental crust and oceanic crust is deep, more denser, that's why it is subducting below. At this subduction point, because it is going downward at very deep, these are called deepest points on earth, like Mariana Trench in Pacific Ocean. So these are called trenches, and these mountains are called volcanic arcs of the volcanic mountains here. So look at the world distribution of volcano. This map is talking about world distribution of volcanoes. Like here we found volcanoes, entire Pacific belt we found volcanoes. So it is showing where volcanoes are found in the world. So look at this. This is the red mark, is the presence of volcanoes. But try to compare it with plate tectonics. All the volcanoes here are possible because it is part of Pacific Ocean. That's why volcanoes are possible, because Pacific Ocean is constantly on a movement and it is subducting below North American plate, Cocos plate and Nazca plate. So here the Pacific plate, this is the boundary of Pacific plate, and this Pacific plate is subducting going down below Nazca plate, going down below Cocos plate and going down below North American plate, and this is continental plate, this is oceanic plate, and this oceanic Pacific plate and continental North American plate, this plate boundary are associated with volcanoes because oceanic plate being denser and being oceanic plate, it is subducting below Nazca plate, Cocos plate and North American plate, making it possible for the formation of volcanoes. And always remember, all the plate boundaries are always associated with earthquake and volcanoes and mountains. So this was the story of volcano. So this was volcano explained in convergent plate boundary. But if divergent plate boundary, how it goes, like suppose this is magma chamber, and one direction is here, another direction is here. So direction is like this, and they are hitting the ground. That means, and this is one plate, this is plate number 1, this is plate number 2, and the magma chamber, the direction is opposite. They are not coming towards each other this time, so it will be divergent plate boundary. But the continental crust is so thick that it cannot diverge. The divergent plate boundary is not practically possible or not theoretically possible in continental plates, but in oceanic plates is much thicker. Oceanic plate is much thicker, and the magma inside it, suppose it comes in this direction and again one in this direction, both are oceanic plate 1 and 2. Now over a period of time, 1 is here and 2 is here, one direction is here, another direction is here, magma chamber inside, and now the gap has been created because the direction has been made and the gap has been created, and it secretly slowly erupts from here. This is called fissure volcano. This is called fissure volcanoes, and these volcanoes are not that violent, and this is called fissure volcanoes, and these are associated with divergent plate boundary. And the Atlantic Ocean, in the Atlantic Ocean the volcanoes are there, and these are fissure type of volcanoes. So this is the volcanoes associated with convergent plate boundary, divergent plate boundary, and some other videos also explain the mantle plume, because sometimes this is the magma chamber and this is the ground, but the ground is so thin that the magma would directly hit it and come out. It don't really need any convectional current direction in convergent direction or in divergent direction. It doesn't need any direction to be specific, or plate tectonics is not that associated to make a formation of volcano, but the ground is so thin that the magma chamber, the convection will directly hit the ground and come out, and this concept is called mantle plumes. This concept is the mantle plumes. So we have understood the concept of volcano starting from the ground till interior core, till earthquake, and till volcano with one convergent plate boundary, divergent plate boundary, which is fissure type of election, and mantle plume, where the crust of earth is so thin that the magma will directly hit it and come out as a volcano. So stay tuned. Thank you very much for your precious time, and like, share and subscribe my channel. See you in the next video.